Alright, hey folks. So we're going to do something today. We're going to do some troubleshooting here. So here we have a heat pump inside of a hotel. Okay, so this system is not running. Right now I got the power off. So let's turn the unit back on. Unit's on. Lights are going through. Stats going through. System is kicking on heat. Reading 69, set to 80. Alright. So we got the unit going. I'm going to set this down here. Alright, it is calling for heat. And now it is just communicating. When it comes to these type of units, it's a hurry up and wait type of game. If you ever have issues with such units, it's always best to check the nomenclature. See what type of refrigerant and electricity you're using. Voltage, I mean. Pull out your schematics. And your fault code list. Now we just wait for the system to run. Still hasn't kicked on yet. Let's make sure. Okay. Switching on to heat, engaging. Fan has kicked on. And now you wait for the heat to kick on. But I've already diagnosed this system. I already know exactly what's going on. I just want to help you guys understand how to troubleshoot something. So you want to always start it off as in normal operation, as if there was no issues at all. Let it cycle through its normal system before you start pulling things out and saying this and that is bad. So far everything looks good. Everything started as it should. But sooner or later here it's going to lock out on what is known as a low pressure lockout. Let's go ahead and wait for that to happen. And then we can show you how to try and find a way to diagnose the issues. Like I said, I've already gone through this system. We're just going to recreate it for a little viewership here. So, we just got to wait for it to lock out. And as unfortunate as it is, you're just going to have to sit through and wait. So, as we look at here, we got the model, make, 265 volts, 1 horsepower motor. There's its cooling specs, its heating specs, compressor specs, refrigerant R410A, 34 ounces, pressure test, high of 600, low of 265. You know, if you're just a regular homeowner, you don't necessarily need this, but hey, if you know it, it comes in handy. If you don't know how to read these, I definitely recommend you check out somewhere so that way you can learn how to read these. It came in handy helping me diagnose what was the problem. Like I said, it was a low pressure issue on here, and I had to figure out through the schematic which valve was a low pressure switch. And when it went into that low pressure lockout, you run the system in test mode where you can check the fault codes. And if you see right now, it's a solid green on with a slow blink red. That's a normal function. Written somewhere on here. I'm not going to read it in full details. But during the test mode, you would be able to change it and go through the actual fault code. So it would blink once, twice, 3, 13 times, depending on the sequence of beeps. It'll tell you the code. So we'll see that here. Like I said, I was getting a low pressure fault in memory code, which was 3 red flashes. We'll wait for this system to reach its lockout point, and we'll move forward from there. And there we go. It is now in lockout. So let's go ahead and turn the thermostat as it is. Head over here, hit the test button. It is running the test sequence. Two, three. 3 blinks. Low pressure fault in memory. Okay, well, let's get rid of that. Exit the test mode. Open your schematic and look for your low pressure switch, which is right here, which I found to be over here on the board, which I then goes to show it's up in that top corner. So I followed those lines up to the low pressure switch, which we will head to next after I get my jumper cord. So here's my gauges. So here's one pressure switch, another pressure switch, but this one right here is my low pressure switch. So this guy is not letting the signal go through to get the compressor running. So we're just going to get a scrap cord, pop it in there, scrap cord, pop it in here, set it somewhere where we're not going to get a charge. Turn the system off, back on. Thermostat is reading 71, set the heat at 80. And heat load. It is now currently connecting from thermostat to the unit. It is now engaged the fan motor. And everything is operating as normal. So here's our fan motor. It's a little funky setup here, and here's where I got my little extra jumper wire. Don't need to cap this in. There's no power on this, and here's power on this side. One of these we gotta water in. One of these, you gotta water out. I haven't figured out which one is which yet, but that's not a concern at the moment. This is your reversing valve, and that is your compressor. Here is your solenoid valve, and this is the device that the hotel has on. I don't know why they got that in here, but whatever. These are your coils. You definitely want to make sure these are clean. You want to be able to see light through there, no black patches. You know, air is getting pulled through here. A little dirty, not the greatest, but a little dirty. Everything's still running in its normal function mode. We still got the jumper cable here. And we are bypassing this low pressure valve with this jumper cable because our error code was a 3 blinks. Oh, low pressure fault in memory. 3 flashing codes. There's the diagram for the low pressure switch. And we look at the diagram of the control board and we find the low pressure switch right there. Okay, on number 3 and 4 of the control board, which then we will take a peek and see that it is up there. All right, so we are still waiting for it to kick on the compressor here. It won't sense the low pressure and give us a lockout because I am bypassing the pressure switch. We're just waiting for it to finish its communications and its startup system, and soon you will hear a rumble of the compressor. Let's get ready. We do not want to keep the system running when there is no refrigerant in the system. So just wait. So like I said, it's the game of hurry up and wait. So in the meantime, we should all be learning skills to help us diagnose and fix our own equipment. So I'm just going to set this up. And we are going to wait. Here, while we're waiting, let's learn a little something. This is called a multimeter. I recommend Fluke. I don't like this one, but I got used to it. I like my own, but this will work. This is volts, alternating current. Volts, direct current. Millivolts, direct alternating current and direct currents. You just got to hit this to switch. It hardly hurts. We have ohms for resistance. Connectivity, that'll let you know if you got a faulty piece. If you have a switch that is normally open, if you have a switch that is normally closed and you need to test if it's functioning properly, this will let you know. I don't use this. And temperature. And there we go. Compressor is on, and we know it's the low pressure. It said units out of refrigerant, so we're going to turn it off. So now all I have to do is Just find out where this leak is coming from. Seal the leak, charge it with some refrigerant, and then the system should be back in working order. Hope this helps out anybody that has a heat pump. Take care. Bye.